lessons on electronic commerce. This time I will make a very quick review in terms of the layered architecture which we looked at. Layered architecture, I said we will discuss each layer so that the discussion is somewhat self-contained, and also during design one comes up with layered architecture primarily to make sure that each layer can be independently designed and that the interfaces between the layers are clean. There is, in other words, the concerns of different layers may be with different people. So there is no need to mix up the entire subject in one big unit if if we kind of make it into layers. So the layers which I described starting from the top was the application layer. So we started our discussion with the application layer. We said what is B2B, what is B2C, and what is C2C e-commerce, and we described each one of them and applications of each one of them. Now then we went back to some extent to the bottom layer. Of course, the physical network we did not discuss in this course, because the physical network consists of the public switched telephone network, the local area network, bridges and routers to connect the LAN to the PSTN or interconnect LANs and so on, because internet depends upon the individual LANs or individual computers being connected by PSTN. That physical network architecture is normally talked about in the computer network course. So that is the reason why in this course we do not talk about it. I gave a very quick view of the logical network, namely the internet, the intranet and extranet. We define internet as a network of networks using a uniform protocol for communication called the TCP/IP, Transmission Control Protocol, Internet Protocol. And TCP/IP is what makes computers of different makers and computers on different LANs to be interconnected and communicate in a uniform language, so that you can have diversity and still have unity in terms of the protocol and in terms of the way in which the system works together. Now we said that the intranet, of course, is a internet using something, internet protocol is used within a single organization. That means they are using the same protocol TCP/IP. Once they use that same protocol, many of the applications which have been developed for the internet can also be implemented on the intranet. And so without too much of extra work, a company or an organization can put all the internet applications on their own local network, and the advantage of doing that is that you have security. You are not connecting it to the internet and making it available or visible to the rest of the world. Within your organization you are working with your own network, but are able to use all the tools which have been developed for the internet. And extranet, we said, is a connection of intranets, in the sense that there are cooperating organizations which may like to do business with one another, and they interconnect their local networks or intranets through either a private line or through a secure line. A secure line being nowadays a virtual private network, as they call it, which has got slightly better security than the public switch telephone network. one can debate whether it's slightly more or it is watertight, but by and large when you start using the public switch telephone network, you do have a certain kind of possibility of intrusion which is not there if you are using a completely private network. But nobody wants to invest on private networks because they are fairly expensive, and it is much cheaper to use the public network with enhanced security. That is what the VPN type of network does, and so that is more or less becoming widely used by many organizations. So we did talk something about the logical network, and then over the internet is the World Wide Web. The World Wide Web is an application over the internet, and the World Wide Web provides certain types of standards and certain types of services. Now the important protocol on the web is the hypertext transfer protocol, which allows the web pages to be linked together, and then it allows the communication or actually being able to look at the web pages of other organizations and be able to also have a uniform method of communicating. HTML is a hypertext markup language, which is the first one which came, which is the hypertext transfer protocol, and HTML is primarily a formatting language, in the sense that it gives you something similar to what a word processor gives in terms of paragraphing, boldfacing, italicizing, and also it has got links to other pages. That is why it is called hypertext, and you can also link to graphics or other video and whatnot. There is other data types other than textual data type can also be linked to the using the HTML protocol, and so HTML has been more or less used as a fairly universal standard for web based communication among organizations in the world. Now one found that HTML does not tell anything about the nature of the contents. It only talks about formatting. So if you want to transfer information such as purchase orders and quotations and so on, one would like to have over and above the formatting also a method of describing what is contained in that web page in terms of some data types which the various parts of the web page has, or you might say in this case a document has. I would really call it as a document rather than a web page. Okay. So a document description in terms of the contents of the document is the aim of XML. More than that, it also allows a certain kind of flexibility in the type of tags you use, which makes it somewhat self-explanatory in terms of the contents. So user defined tags and data type definition language goes along with XML, and XML has been widely used and has become standard. Of course, all the time there are new variations coming and improvements coming and so on. There is a wireless XML and so on, and people are continuously actually improving those things. In fact, when we talked about these things, we didn't talk about software agents, which are really programs with a little bit of common sense or intelligence, which are able to do a slightly better job in terms of describing content and being able to retrieve in a search engine and so on. We didn't really talk about that. We also didn't talk about the object linking and so on, because that is not entirely relevant to our discussion. Now, over this, once you have a logical network and a World Wide Web services on which you can transfer email, transfer files and have web pages and so on, and transfer documents using XML, the question of security of the transmission of messages come up, and so we talked about the secure messaging, that is encryption methods. We talked about both the public key encryption and the private key encryption and the advantages of one over the other. And these are essentially, encryption is primarily for security of the messages you send, and firewall is more of a hardware unit, you might say. Of course, you can implement some of the firewall functions through software, but most companies have a machine which has this function, which does a filtering of communications between organizations. That is, what comes into the organization, what goes out of the organization, all that is really filtered by the firewall. And electronic data interchange, in fact, is something a little bit more about the web, more than web services, because it is a standard which in fact one can implement using XML, but it predates XML in terms of the early messaging system, and to some extent the EDI is put into a secure envelope, and that is what is exchanged. Over that are the so-called middleman services. What is meant by middleman services is, we said that in any public key encryption system, in order to be able to certify a public key, which is essential for digital signatures, you have a public key certification authority. That is a middleman service. In other words, it is something which, a service which is provided for you to be able to make use of the network for electronic commerce. So, these are digital certificates which are given. Payment services, we looked at credit card payments, spent a fair amount of time on how credit card payments are kept secure, and various protocols for doing that. And in fact, the middleman services requires security aspects embedded into it. The point I am trying to make is that the service is carried out by an organization, like in the case of a credit card payment, there is an acquirer and there is a bank, which are the ones which are intermediaries between the vendor and the customer. And so, this is they make their money as some kind of a broker between these two. The other kind of middleman services we talked about are the certifying agencies, and we talked about the possibility of value added networks which provide you 24-hour secure communication with also digital certificates given, and audit trails being kept and so on. So, that is a kind of another middleman service, you might say. And hosting service. What is meant by hosting services is that the web page of your organization you may not like to keep in your own computer, because that will be approached by a lot of people and it could be a security hole there. So, there are companies which provide servers on which they host your web page and provide you an appropriate link as required. But as far as a general layman or lay user is concerned, he will log into the hosting services machines, so that he will not be able to intrude onto your network. So, many companies have a third party hosting of their web pages and so on. And that is what is meant by this hosting services. So, digital signature requires certification, and payment, we said we have payments like check, the credit card payments, for which of course the bank and acquirer are involved. Check payment, which again requires encryption, and there are the bank and in the electronic funds transfer between banks, which are all middleman services. And then we talked about NetBill, the company which is actually a middleman company, which provides a method of paying for small amounts for information such as music files, video files or text files, by encrypting them and providing the key when you pay for it. And then the NetBill, of course, is the agency which is the intermediary between the seller and the buyer, and they make sure that the information which the seller gets is authentic, and that the buyer pays the appropriate amount to a seller at the appropriate time. So, this is essentially the service they provide. And lastly, we talked about cash transactions, primarily small cash transactions, because large cash transactions are normally not allowed in many countries for various security reasons. And so, small cash transactions take place, and here again you might say electronic coins are the ones which are issued by middlemen services such as banks, and then they keep track of spent coins, so that the same coin is not spent over again. It does not have the same advantages of good old cash, because anonymity is not preserved. That means who paid it and not preserved. And also one more important thing about cash is that if I pay you some money, you can pay it to somebody else to buy something without the first person knowing anything about what you are going to use that money for. So, in other words, the money is kind of universal exchange medium, cash, whereas electronic cash is not a universal medium. It is issued by a bank, only you can use it. To give it to somebody else, that person cannot use it, because once you use it, it is called a spent coin. Once it is spent coin, the bank will dishonor it. So, the whole point is that it kind of not a complete analog of real cash, but it is a reasonable analog of real cash for small cash payments. And that is what the middleman, one more middleman services we talked about. Of course, application layer we spent a fair amount of time about these three things, because most people only talk about the application layer, they do not really talk about the rest of the layers. But as a computer science student and as a student who is going to be designing some of these things, it is important for you to know what is beneath that top layer, namely B2B, B2C and C2C, and what are all the things that are important for you to consider when you look at say for instance, when you are advising a company on e-commerce, you got to kind of be able to advise them in a more educated way in terms of what are all kind of security systems are available and how secure are really the security systems, and also the various formatting method. In fact, XML and so on is very, very important for people to know. And of course, HTML is taught many places just to be able to create a web page. Okay. So, these are all becoming more or less standard, and so in a first course in systems analysis and design, in many of the books they do not talk about e-commerce at all, but I did make a decision that because a lot of systems are going to go towards the web, and web is an intermediary, it is important for students to understand what the implications are, and also the fact that e-commerce is a growing area where many companies are going to get into, and also the supply chain management is a very important part of any company's day-to-day working. So from all those points of view, and supply chain is much better controlled or much better, you might say, organized and so on by the availability of e-commerce type use of internet or intranet and so on. So the slowly the world is going towards a situation where every computer is connected to every other computer in the world. Once you have the situation, no system can be designed in isolation. System has to be designed keeping in view the fact that you are going to be part of a large worldwide network. So in this case, you got to understand all these implications of this and be prepared to design systems on this. In fact, one of the trends, and people say that the next decade or so it is going to become more and more important, is the computer architecture itself is becoming service oriented architecture. Service oriented architectures in terms of the machines and all the layers which go to it to be able to provide services over a network of machines all over the world. So there is also a trend towards what I would say pay by use computing, and all these things are emerging, and I as a student now you have to understand the implications of this in the long run during your own professional life. That is the reason I spent a fair amount of time on this. Okay. Now the rest of the talk I am going to devote to talking about something called case tools. The case, CASE, case stands for computer aided software engineering. Primarily we are going to talk about what are case tools and why are they important, and how do we use some case tools. Obviously in a lecture how to use cannot be talked about in any great length, it will only bore you. You only know how to use by using it. So I am going to give you certain URLs of certain case tools available in the open domain, so that you can actually play around with them and start using them in your projects and so on. So the purpose of this particular talk is to introduce you to the idea of case tools and also tell you about some of the existing tools for you to be able to use it, and more importantly, the students should make it a habit to use case tools, in the sense that there is no point in reinventing the wheel every time. A lot of things have been done already and they are freely available. So whenever you design a new system, you should be able to use that which somebody else has done for you and probably even tested it fairly well, because when something goes on the web, a lot of people have used it and they have sent feedback and the developer has also used this feedback to improve, and hopefully many of these open domain tools will have less bugs because they have been removed over a period of time. So in this particular module then we will talk about what are case tools, why are they important, when are they used, and how are they used. So that is what the various points I want to mention are. Now the reason why we talking about case tools, as in other words, what is case tools? Of course, I probably have to say in the same thing. CASE tools, CASE tool stands for Computer Design Engineering Tools. So, CASE. As the name implies, they are computer based programs to increase the productivity of analysts. In other words, it gives you certain types of pre-designed systems which allows you to very quickly do the analysis and design which you want to do. A lot of clerical thing goes into the analysis and design, and a lot of those clerical things are the ones which are taken care of by the CASE tools. Because any design, there are certain parts which are clerical, you might say, and certain parts which are intellectual. The intellectual part you have to do really, but the clerical part is where the tools come in. Just like when you write a book, the clerical part is word processing and so on. The intellectual part is actually coming up with the idea and writing the structure of the book and deciding what has to go where, how to organize and so on. So, that is the part which is purely intellectual. But word processor does improve your productivity. It makes it faster for you to do your work. They permit effective communication with users as well as other members of the development team. In other words, if you can create a so-called rapid prototype, so you can make a look and feel system of the ultimate system you are going to design, which can be given for approval to the user. And so, this is called rapid prototyping. So, you give a kind of a, you don't put everything into it, but you give a, you might say, a sample of how it is going to look like, look and feel as they call it, look and feel of what the system will be like when it is completely implemented. So, that is essentially what the CASE tools also allow you to do, that kind of prototyping. The reason why we are going to be talking about CASE tools, industries routinely use CASE tools as productivity aid to reduce their development time. For the system development time, the tools are a great help in reducing the overall time. For instance, let me take an example. If your company provides some system for a bank, once you design a system for a bank, if you design a system for another bank, a lot of things are common between these two banks. So, if you create a whole lot of tools which make it possible to kind of parameterize many of the changes between banks, the tools are very easily usable from one application to the other application. So, they are, apart from that, this is of course particular to a particular application, but there are certain general things like data flow diagrams are used everywhere. So, data flow diagramming tool is something which is a useful thing to have. ER diagram is again used quite a bit. So, some tool to allow you to make up ER diagram will be nice to have, and they will increase the productivity and reduce the time, because ultimately the profitability of a company in services area is to be able to give the system at low cost in a short time. Time is also of great consequence. So, a student should know what these tools are and how are they useful. That is the reason we are going to talk about this. The intention of this module is not to make you an expert in the use of these tools, but to make you aware about them and the importance and their importance in industrial practice. As I pointed out, see, no lecture can give you something about how to use a tool effectively. You have to use it to understand how it works. So, what I can essentially tell you here is the importance of them and the fact that they are very important and very useful to improve your productivity. Okay. The CASE tools integrate the development done during each phase of a system design cycle. we have a distinct system so-called life cycle which we talked about, starting with requirement specification and going ultimately to implementation, and also the review, post implementation review. So there are a number of different steps we talked about, and we said that software engineers sometimes call it a waterfall model, but then no system is developed entirely in one track. You normally do one or two parts and then go back and kind of change. That is, in other words, once you come up with the requirement specification, you go to the next step, and if you are having some problem in implementing that requirement, you have to go back to the user and ask for revised requirements, saying what the difficulties in implementing the particular requirement, or the cost implications or time implications, and so you can prioritize it. So in other words, you don't wait till the end before you talk about possible revisions. You essentially do a more of a spiral type of development. There is feedback at every stage, to a previous stage maybe, or even 2 steps earlier, to essentially find out that the entire process is iterative. It is not really a straight system, but it is an iterative system. The case tools also correctly assist you correctly assess the cost of changes. So the changes which are requested by the user requires time and effort, which translates into money. So one should be able to estimate what is the cost of this maintenance of changes and so on. And the use of tools does allow you in certain cases to be able to estimate this extra cost because of the changed requirements and so on. There are lots of commercially available tools. There are actually program packages sold by many vendors for each phase of the system development life cycle, starting with the system requirement specification to feasibility analysis to the system design and process specification and things like that. And there is one tool called Visual Analyst, which has several tools integrated together to take care of all the life cycle phases in a system development. But this tool is extremely expensive, because many large companies will have several copies of these tools, and they will be, because of the fact that they are a profit making organization and they have to reduce the development time and use the productivity of the analyst and programmer more, they will actually buy these tools at sometimes very high cost, sometimes few lakhs of rupees. Whereas in an education institution, one can't really afford to buy these commercial tools, for the simple reason that they are too expensive, and they are not really necessary to teach. What is necessary to teach is to give you an idea of how it is to be used and what they look like, and not the bells and whistles, as they say, of the full-fledged commercial tool, which provides a lot of frills. So that's the reason why I am going to talk only about open domain tools, because most colleges cannot afford to buy Visual Analyst and things like that. It's too expensive. So open domain tools is what we are going to be talking about, which can be downloaded freely, and most of them fortunately use only a PC, require only a PC, and of course PCs are there in plenty, and they normally require a Windows operating system of Windows 95 or above, which of course most people have now. Doesn't really require you to get the most recent Windows version like Windows NT or what is in the horizon and so on and so forth. But a reasonable windows is sufficient, and also you require a browser like Internet Explorer or Netscape, and of course you need to have an internet connection to be able to download this tool. They don't have very good user interfaces. The graphical user interfaces which are provided by these open domain tools are not very good. I mean, that is the advantage of commercial tools. They will provide you very good user interfaces, and some of them provide you very good documentation also, teaching aids and whatnot. Open domain tools, well, some of them are good, some of them are indifferent. So one can't really say that the tool has uniformly excellent documentation and so on. Okay. But the advantage is many of these tools, they provide the source code also to you, and you can understand the source code, maybe even improve it. Not everyone will provide, but some of them do provide. The available case tools are particularly in the open domain are systems requirement specification documentation tool. That is, once you write the system requirement specification or the SRS, you are document the SRS, and you have to be able to show it to the user and get his approval, and it may have to be shown to different levels of people. And it is a very important document, because once the SRS is approved by the user and it is signed and you might say sealed, that then it is frozen. And so later on, if any changes in the SRS are required by the user, then the vendor has got every justification to be able to charge more, because it is in deviation from the original SRS. So the amount of time spent and designing an SRS carefully is well spent, because if you have a very good SRS which has been agreed to by the user also, then later on you don't get into trouble. The later you find out some difficulty, the more expensive it is to fix it. So it is much better to clarify all doubts early in the game when you are starting the actual design. So it is very important for you to spend a fair amount of time at this stage. There are tools available for making data flow diagrams, things like leveling diagrams, things like any errors in the data flow diagrams which are not allowed by the syntax of the diagrams, like for instance a data flow going from file to file, or a data flow essentially trying to update something from the external entity and things like that. We are not allowed, is detected by this diagramming tool. And you have a system flow chart, which is a pictorial representation of the various steps in the system design process. System designing, the flow chart designing tool, generation tool. That is, you actually can generate the system flow chart by using the appropriate symbols, standard symbols. The standard symbols are in the library of symbols. You can drag and drop and make a complete picture, and it gives you a neat picture which you can discuss with the user. Also make sure that it is in multiple pages, then the proper connection between pages is maintained. So the system flowchart generation tool is important. Data dictionary creation. given the data flow diagram and what all is contained in the files, alphabetizing the data dictionary, creating a data dictionary and so on, is again a clerical chore which is done by this tool. Formatting and checking structured English process logic. The process logic, you can have a nice structured description with the proper indenting and so on, and sometimes some simple logical errors can be pointed out in this system flow chart. Apart from that, apart from structured English, we also said that for a complex decision making process, you work with decision tables. There are two aspects of decision tables. One is the logical correctness of the table has to be checked, and there are many tools to check the logical correctness. Apart from the logical correctness checking, which is very important, you can generate test data from this table. Test data generation from decision tables is another tool which is normally available. And thirdly, you can convert automatically a decision table to an equivalent program in a language such as COBOL. So there are open domain tools available to convert decision tables to programs in some high level language, and some of them try to also even optimize it given the frequencies of occurrence of various rules and the estimates of time taken to check the various conditions which are relevant in the decision table. These are also interesting tools which kind of reduce your effort in program writing and reduce also the error which you make in program writing. Screen design for data inputting. Data input, as I said, is extremely important in the sense that it is done by operators very often or by lay users, and you got to kind of give them reasonably nice format. And we talked about form design, and we talked about good methods of form design and bad methods of form design. So a tool which uses the good practices effectively and creates a nice screen, because many of these input systems, they are based on screens on the PC. So this kind of form design tool is very useful to have. And entity relationship diagram is an important part of any database creation. So once you specify what the entities are and what relationships are, then actually a diagram can be drawn, because after all it's a picture. And again, the tool is available for diagramming tool. It is not the entity relationship model itself, it requires intellectual inputs, because a relationship is something you have to know and you have to judge. A machine cannot do that, fortunately. A machine can only allow you to do a pictorial representation. Database normalization also, given the dependency information. See, dependency information is something which only you can give, because that is semantic again, whereas the normalization steps are somewhat mechanical. So there are some very intelligent tools which do some normalization. So at least first cut normalization is done, so that later on you can kind of check it out and improve it, so that you have a certain aid in doing it and reduce the time taken to do it. Normally tools are used throughout the system design cycle. It is not as though there are tools only for certain steps. Throughout the system development, there are different varieties of tools available for each step. And so something like visual analyst and so on, commercial tool, nicely integrates all these together and provides you an integrated view. Whereas when you start using open domain tools, then integration is not available. You got to at least, you have to use and select the appropriate tool for the appropriate job, and that comes out of practice by actually doing it on certain case studies, which I will talk about in the next lecture. Case tools are sometimes classified as uppercase tools and lowercase tools. This is an arbitrary classification. The tools which are described so far are not very intelligent tools. They are essentially tools which help you to reduce your clerical chore. They are called uppercase tools. Tools are available which will generate computer code from higher level description, such as in structured English and decision tables. They are called lower case tools. In other words, they are more intelligent in the sense that given the structured English description, a high level language program comes out as an output. That means using all the syntax rules and semantic rules of the high level language, some automatic generation of that program takes place. Decision table to program conversion tools have been there for a long time, almost 30 years. I remember to have worked on it myself in the mid 60s. So there are plenty of such tools available, which are called actually lower case tools, because of course they are more intelligent tools. It requires more intelligent programming, and many are very often certain kind of optimization. If it is a good lower case tool, it can save you a lot of time in program writing, and also to some extent if automatic test generation is also there, it will also test that program. Because these are kind of utopian, very often people don't do that. They still, programming manually is a very big part of the job of any entering graduate student, if you enter a company from the college, the first kind of jobs they give you was to test existing code, read existing code, and you don't really get into development right away. You get into development slowly. And there are a lot of object oriented, because as currently the practice is going towards object oriented system design. Apart from away from so called structured design. Structured design is the earlier approach, and it is not completely relegated. It is not a kind of you might say it is not thrown away. It is still useful in smaller systems. But when you have a very large system and you want to do a lot of reuse and so on, then the object oriented techniques becomes important. We did talk about object oriented systems design in this course, but we didn't spend the entire course on that. There are certain courses at a higher level which talk about object oriented design from step 1 to the last step. Okay, it's a different mindset, you might say, but it is important in terms of the fact that there is a trend for various reasons, including reuse, including primarily the fact that reuse is probably the most important reason why people go towards object orientation. Okay, and because reuse is it saves a lot of money for you. Okay, and it's also because modular design is possible and so on. Something called a unified modeling language is the current standard, which is again standard for object oriented design, and is universally used. There is a company called Rational Rose which markets as UML tools, but again very expensive, and again I don't know many institutions which buy this Rational Rose and so on. And but when you go to a company, start working there, they will have such a tool available for you to use, and it will take a long time for you to first learn how the tool works. That's part of the training they give you. Okay, so we will not talk about that in this course, for simple reason that I have not used it myself, and we don't have access to it. And also, this course is not about AML and object-oriented design. Most tools have user's guide, which is given as help files along with the tools. That is normally in both commercial tools and in open domain tools. Some help files are there. Many have frequently asked questions, FAQs, and search capabilities. If you get into some doubt, you can actually type those words and so on, and they will search and try to kind of retrieve some part of the documentation to help you. Data in several open domain tools and what they do, I am going to talk now. There is a tool called Smart Draw, and that is available in www.smartdraw.com, as the name itself is used, and any PC will do. As I said, above Windows 95, at least 20 MB free space on your memory, Internet Explorer, and Netscape. It draws flowcharts. Smart Draw, as the name implies, it is a drawing tool. It is useful for drawing flowcharts, system charts, ER diagrams. It has got a huge library of, you might say, templates. You can drag the template and drop it wherever you want on the screen, interconnect by lines, and create all these nice drawings, and then you can print it out. So you don't have to sit down with your paper and pencil and do a lot of drawing. That is the advantage of this Smart Draw. It is a reasonably good tool. I have seen it being used, and I have made my students use it. It has got an online tutorial so that you can learn about that tool, how to use it, and so on. So anybody with a reasonable amount of practice on a computer will be able to kind of download this tool from the internet and use it and learn about it from the tutorial. And of course, more than that, you learn by practice. You make a mistake and you correct it, and when you get into doubt, you go into the tutorial. By and large, people don't start by reading the entire manual. They start using it, and then when they get to doubt, only then they go to the manual. That's human nature. There is a tool which is given by IBM, the data flow diagram tool, available in viu.eng.rpi.edu. It is not really IBM's tool. It's RPI is the Rensselaer Polytechnic Institute. It is a tool developed by the students there, and the URL is given there, viu.eng.rpi.edu. Again, use a PC, and it does DFD modeling, it does DFE leveling, and so any mistakes in drawing DFD is detected by this tool. And so it's got also an online tutorial for you to learn about this tool. There is an open domain tool called COPE. URL is www.cs.adelaide. There is Adelaide University in Australia, and .edu. I think that it should be .au if I am not mistaken. I think .com is normally used for commercial sites. It must be AU, it's Australian University. .edu.au/users. .dir examples HTML, and it converts decision tables to COBOL source code. In other words, you provide decision table in some particular format and converts it into a small program. I am giving an example of this. So, online manual is available, and the table is given. In fact, normally the conditions are given on the left and rules are given on the right in a table, but here in this the conditions are given as yes, no, and so on. Now the rules. The condition is if A equal to 0 is called is A equal to 0 and is B equal to 0. For two conditions are being checked, and the actions are X for carrying out the action, dash for not carrying out the action. So it will interpret as if A equal to 0 and B equal to 0, then move 0 to C. If A equal to 0 and B is not equal to 0, then move 0 to C and add 1 to C. And if A is not equal to 0 and B is 0, add 1 to C. And if both of them are not equal to 0, A and B, add 1 to C. Obviously, there is a redundancy in this, and you can combine the last two rules into a single rule, no dash. Okay, but then this tool will actually automatically do this for you. There is another tool called ARMM, Automated Requirements Management, and it is a NASA tool from the government of USA, and the URL is given swrens.gstc.nasa.gov/disciplines/quality/index/php, and this is a program to allow you to come up with a requirement specification document, and aids in writing SRS, written as a text file, scanned, gives reports on impreciseness and apparent incompleteness. Does a little bit of a checking of the SRS, not a complete foolproof checking, but reasonable checking. Online manual is available, readme.doc file, and that same one. Okay. And of course, Visual Basic is is something which is Microsoft provides. It allows you to do a lot of good GUIs, all this radio buttons and toolbars and stuff like that. So Visual Basic is a very useful language to learn, to particularly create GUIs and particularly for rapid prototyping. It's very useful. So this concludes my discussion of case tools. Next time we look at some of the case studies, which will be the concluding lecture of this series of lectures. Thank you.